Evening, students. Welcome to our third lesson. So last week we were looking at the rules for differentiation, and we were looking at questions that would be considered level 2 type questions, so something that would be fairly routine. Normally what you'd find in your matric paper is that after they've given you the question on first principles, the next two questions will be ones on applying the rules. So what we're focusing on today is, well, what we focused on last week was the first of these differentiation type questions, and today we're focusing on the second type. So these ones are a little bit more complex. They require splitting and factorizing, but we're going to talk about that now. Hopefully you guys managed to do questions A, B, and D. So that was just a reminder from last week. So I'm going to ask a couple of people if you can maybe share some of your answers with me. Recho Meditswe, are you there? Did you try A? You can send me a thumbs up. Okay, what did you get, Recho Meditswe? Either you can type it or you can turn your mic on. Oh, Recho Meditswe is requesting to join. Okay, Tsepo, what about you? Did you try question A? Did you want to share your answer with us?
Yes, I did try A. I got x to the exponent negative half.
So let's have a look here. So you've got x to the exponent of the negative half. There we go. I got the same answer as you.
Minus 8x. Sorry?
Sorry, I interrupted you. I beg your pardon. Keep going.
Yes, I did get it right.
You did too. Okay, I'm sorry I interrupted you, Tsepo, but that was perfect. Well done. All right, let's call on somebody else. Recho Meditswe, are you with us now? You were here earlier?
Yes, I'm here.
Oh, good. Did you get a chance to try question B?
No, I only tried the first question and I got the answer right.
Yes, I saw you got cut off. Let's see if there's somebody else. What about Virginia? Virginia, did you manage to try question B? I don't know if Virginia can hear us. Okay. Neo, did you manage
I'm doing it right now.
Oh, okay. All right. That's fine. That's fine. Neo, did you manage to do question B?
Ma'am, I just joined. So,
Ma'am, I said I'm doing it right now.
Okay, that's fine. Not a problem. Right. What we can do is just finish the question that we're on, and then we're going to have to mark them and then proceed onwards. Okay, so Sake's just asked a question. Ma'am, I took my exponents to the denominator to make them positive. Sake, you can do that, but it's not necessary. At matric level, they will mark your work correct with negative exponents in calculus. So you don't have to take them into the denominator to make them positive or into the numerator to make them positive like you were expected to do in grade 8, 9, or 10. All right. Okay, great. All right, so let's have a look at question B quickly, and then we can jump straight into our lesson. Let's not worry about D. Maybe we can try that next time. This is what I got as my answer for question B. So I got the derivative of y with respect to x is minus 12x to the power of minus 3 plus x to the power of negative 7. Can you give me a thumbs up if you got the same answer? Okay, good stuff. 2 thumbs ups, 3 thumbs ups, good stuff, well done. Anybody get a different answer and they're not sure why? Are there any questions about how we would do this? Oh, 6 thumbs ups now, that's great. Do you also notice, Matrix, how whilst I was still preparing the statement for differentiation, can you see I wrote y equals and then I wrote y equals again, because all I did from line 1 to line 2 was move variables from the denominator to the numerator. Okay, and then when I applied my power rule, that's when I wrote the derivative of y with respect to x. Okay, well, I'm glad that there were 7 thumbs up. That's really great. Let's move on and get started with our lesson. Okay, so just a quick prior knowledge check. We saw this last week. How do we determine a derivative? Okay, so let's call on Malu. Do you remember how we take a derivative? Malu, are you there?
Yes. Hi, ma'am. Ma'am, what do you mean? Like,
So in
how
other-
do we do it?
So in other words, if you're given an expression and you are expected to derive it, what do you do to the expression?
You first have to prepare it by removing any radicals.
Yes.
I don't know. I can't remember the other two.
Radicals, divide lines,
And
and brackets.
brackets.
And brackets, that's right. Okay, so those have to be removed. We're going to talk about removing the divide lines quite a lot today. Sorry, what I was trying to get at is that we're going to apply the power rule. So we're going to multiply the exponent with the coefficient of the term and then subtract 1 from the exponent. Okay, the other thing that we need to remember, the derivative of any constant is 0. And there we go. That's what you were saying, Malu. We need to remove radicals, brackets, and divide lines. Okay, radicals, brackets, and divide lines. So radicals are roots, brackets we know from FOIL or squaring binomials, and divide lines. Now, we saw a little bit of that last week, but we're going to concentrate on that a little bit more. And then the other thing that we need, another skill that's important, although it's not determining the derivative, but a skill that we need, a prior knowledge skill, is we need to be able to factorize. So we've got to make sure that we can factorize difference of 2 squares, all trinomials, sum and difference of cubes, which you may be a little bit rusty on, and there could potentially even be a question with grouping in it. All right, so I did find one like that. I have set it on the side for us. I don't know if we're going to get there today. Okay, so let's jump into this situation over here. So the first situation is, what happens when you are given a monomial denominator? So in other words, there's just one term in the denominator. What we need to do with questions like this is we need to split the question up. So this is probably something that you learned all the way back in grade 8, right? So keeping our notation, we're going to do this. We're going to split the numerator over the denominator. But what I can do at the same time is I can remove my radicals as well. So in other words, I'm going to write the cube root of x squared. That's okay, Atim Korsi. Are you with us now? You hear Atim Korsi?
Yes, ma'am.
Oh, that's awesome. Well done. Welcome.
I'm
to
so
the
sorry
lesson.
I'm late. I'm so
It's-
sorry I'm late for the class.
Don't stress. It's not a big deal. While I'm chatting to you, can you remember how we remove radicals and how we would write a base with a rational exponent?
Not really. I don't want to lie.
Okay.
My mind has been busy the whole day because I was at work.
Okay, that's all right. Okay, so hopefully everybody, you remember how to do this from last week. So we're going to keep the base and then we're going to write it to the power of 2 over 3. So Atim Korsi, one way of remembering this is what I tell the students I teach every day, is that the guy at the bottom got kicked to the outside of the party. Okay, so because he's sitting out there outside the radical, he's on the outside of the party. So the guy at the bottom gets kicked to the outside of the party. All right, maybe that will be helpful to you. All right, minus x to the power of a half. And then what we're going to do is we're going to split this denominator up. So in other words, we're going to write it over here and we're going to write it over here as well. So we're going to write this as x to the power of a half and we're going to write this as x to the power of a half. So what I'm doing here is something that you actually are familiar with. If you've seen a fraction like this in the past, so let's pretend you had something like 2 plus 3 over 7. All we're doing is we're writing this as 2 over 7 plus 3 over 7. That's the process that we're going through right now. Okay, so it's quite simple. We're still not ready to take the derivative. So what we're going to do is we're first going to simplify each term. So there's an exponent rule that says when we divide like bases, we subtract our exponents. So that's going to be our next step. Okay, oopsie daisy, didn't write that very neatly. Okay, so we're going to keep our base x and we're going to say 2 over 3 minus a half. Now you could work that out on your calculator. If somebody wants to do that for me, maybe Nala, can you work that out for me? 2 over 3 minus a half, what would you get?
I got 1 over 6.
1 over 6, that's it. Well done, thank you very much. Okay, and then as far as the second term is concerned, can everybody see that we've got x to the power of a half divided by x to the power of a half? And we all know that in maths, anything divided by itself is 1. Always, always, always. Okay, so here we're going to write minus 1. Now we are finally ready to take the derivative. We've prepared our expression. We can see each term clearly, the sign, the number, the variables in the numerator, and we've got an exponent. So now we are ready to drop the dx, we're ready to drop the square bracket to tell whoever's marking our work that we have taken the first derivative. We simply write equals, and now we apply our power rules. We're going to say 1 over 6 times the invisible 1 in front of the x. That gives us 1 over 6, whoopsie, I'm squashing it in here a little bit, x, and then we need to take 1 away from the exponent. Okay, so Sake, could you answer that question for me? If I take 1 away from the exponent, what would I end up with? Negative 5 over 6. Excellent. Perfect, perfect, perfect. Well done, Saki. That's 100%. Okay, so I'm just going to squeeze that in. My apologies. I hope everybody can see my tiny handwriting over there. I should have left more space. And then what's going to happen to the minus 1? Sepo, can you remember from last week what happened to minus 1? It becomes 0, 100% Sepo, but we're not going to write plus or minus 0. Okay, so when we've already got another term in our expression that isn't 0, we don't have to write 0 as an answer. Quite right. So that would have been the answer that you got. Okay, so your final answer would be 1 over 6x to the power of minus 5 over 6. Right, and you can leave it with a negative exponent. All right, so enough about me. Now it's back to you guys. I've got another question here, and you're going to show me that you understood. So I would like everybody, please, to try this question over here. Question C, is it big enough? I hope it's not blurry. Okay, so you try that question quickly, and then we're going to talk about what you got. And as soon as you've finished it and you think that you've got it right, then you can send me a thumbs up, please. Okay, Tumelo, how about you? Have you managed to work out an answer yet? Okay, so there's a thumbs up there. Good. Ma'am, please may you scroll up. Not a problem. There you go. Sorry, I should have left that in your view. Okay, so I got one thumbs up from, I think it was you, Neo. If that is indeed the case, then I was going to suggest you could try question H, but maybe you want to hang on and do something a little bit more difficult. Okay, Ozayo, how are you managing with question C? What have you got? Okay, so Isaiah, you've sent me a thumbs down. That's fine. That's not a problem. What are you struggling to understand? Can you put something in the chat? Okay, Malu sent a thumbs up. Good girl. Thank you. Isaiah, what are you struggling with? The whole thing. Okay. Isaiah, did you remember to keep the dx in the square brackets? And then did you try splitting each term of the numerator over the denominator? Because that's the first step. Yes. Okay, so I don't know if you're able to turn your mic on or not, but if you could tell me what I don't know if it's possible for you to just say it rather than type it. If you could say what your first line of working looks like. Is that a little bit difficult, Isaiah? Okay, so I'll tell you what, let's do this. Does your first line of working look like this? So you've still got the dx, you've still got the square bracket, and then what you're doing is you're writing x squared over 2x squared. And then you're writing minus x over 2x squared. And then you're writing minus 6 over 2x squared. Sake, you've got a thumbs up. That's great. Thank you so much. Everybody else that's struggling a little bit, is this what you had in your first line? If you did, then you can send me a thumbs up. If you didn't, you can send me a thumbs down. Okay, so lots of thumbs ups coming through. Yes, Isaiah said, yes, I had that. Great, that's wonderful. That's the first step. So normally in maths, when you can conquer the first line, you're well on your way to being able to solve the problem. Brilliant. Okay, so now our rule is we want to apply the power rule. And we cannot apply the power rule when we have variables in the denominator. So we have to bring variables to the numerator. But sometimes what happens is that things cancel down. So if we have a look at our first term, Isaiah, can you see that we've got an x squared at the top and we've got an x squared at the bottom? Can you tell me what x squared divided by x squared is? You can put it in the chat. X squared divided by x squared will leave us with? That's it, quite right. It'll leave us with 1. Perfect. So in other words, our first term is now going to be 1 over 2 because x squared divided by x squared is 1 and a half times 1 is 1. Now let's concentrate on the second term, okay? What's going to happen here is that an x at the top is going to cancel with an x at the bottom, but there's still going to be an x left over at the bottom. Oh, I think the yellow is not a nice color for me to use. Can you see that there's an x left over? Let's choose green. Can you see that there is an x left over at the bottom? So what we would be required to do, great, you've got a thumbs up, is take that x up to the top. So in other words, our coefficient, the number in front of our variables, is -1/2. There's a 1 at the top and there's a 2 at the bottom. Then we need to take this x from the denominator into the numerator, and we need to remember to change the sign of the exponent. Okay, and then we're going to have to do exactly the same thing with the last term as well. So what we would do here is we would say -6 divided by 2 is -3. There's our number. We're not allowed to leave x squared in the denominator, so when we bring it up to the numerator, we have to change the sign of the exponent. Okay. You want me to zoom in a little bit? Okay. Is that better, Tioni? Can you see a bit better? Okay, and now I would be ready to take my first derivative. Pleasure, Tioni, not a problem. Now I'm ready to take my first derivative. So because each term is written, sign, the number in front, the variable in the numerator with my exponent. So now I'm ready to apply my power rule. I'm differentiating, I'm taking the first derivative, and I know that as far as constant terms are concerned, the derivative of any constant will be 0. So I'm not going to write the 0, I'm going to hang on. I'm going to look at the second term, and then I'm going to say to myself, a negative times a negative is a positive. Okay, and then 1 times a half is a half. So positive 1/2. Write down my x, and from that I need to take away 1. So if I'm sitting at -1 on the number line and I take away 1, then I'm going to end up at -2. Right, and then I'm going to repeat that procedure again for the second one. So in other words, I'm looking at the third term and I'm saying -2 times -3 is +6. Okay, and then as far as my x is concerned, I'm going to write that down, and then I want to take 1 away from -2. So that's going to be to the power of -3. Okay, so I know there are a little bit of issues with that question. Some people find it quite difficult. Does that make sense? Are you happy with that? If you can send me a thumbs up, please. Live, thank you. Thumbs. Okay, so there's lots of thumbs ups coming through. Lovely. Ooh, someone sent me a scared face. Oh, and a sad face. Okay, with a sad face, that's fine, and a thumbs down, we've got another nice, easy one for you to practice, okay? All right, so let's go over here. My buttons have moved out the way, but that's not a problem. Okay, and here we go. Let's try, and there's a beast question here as well for someone who's feeling brave. There we go. So hopefully now you can see the working out from above, so you can use that to guide you. And it's a little bit bigger. Do you want me to make it bigger still? Don't know if that's too big. We're sort of losing some of it. Okay, so now here, I was going to make the suggestion that you do too. All right, so I don't know if you remember from the last couple of lessons that we've had, the green is the easiest, purple is medium, and then orange is the most difficult. Okay, Tioni, not a problem. We can explain that again. All right, so everybody else, you can carry on. If you are confused like Tioni, then you're welcome to listen to me. I'm just going to give you guys a few minutes to work on those questions, and then we'll talk about the answers. All right, Tioni, have you done calculus at school yet? Work that out. Tioni, have you done calculus at school yet? We just started it, but I'm finding it hard to understand. Okay, well, I can completely appreciate that because, I mean, it's a completely new section. You've never done anything like this before. And if you've only just started it and this is the first time you're hearing this, I can appreciate why this would be difficult for you. But remember, your teacher in school is also going to go through this. And then you'll also be able to refer to this video and you'll be able to watch all the videos on Watobi. So hopefully that'll help. Okay, so Tioni, when you are given just one term at the bottom, you have to split each term in the numerator over that term at the bottom. So just like if I wrote 2 plus 1 over 5, I would split that up and I could write that as 2 over 5 plus 1 over 5. That's what I'm doing. Okay, so the first thing that we're going to do is we're going to split it up. So keeping our notation, because we're not differentiating just yet, we're now going to split things up. So what should I write in the first term, Tioni? What is the first, if I've split it up, what's the first thing I should write? Do you know, Tioni, do you know what the first thing is that you should write?
T cubed over 3. I mean, T.
Perfect, perfect, perfect. Well done. Okay, don't go anywhere. Okay, that's 100%. Okay, so T cubed over T. Fabulous. And what should I write as the second term?
Subtract T squared over T.
100%. You've got it. Okay, and then the third term?
Plus 1 over T.
Excellent. Okay, you've got it 100%. Are we ready to differentiate?
Yes, I think so.
Unfortunately, we're not ready to differentiate if we've still got variables at the bottom. So do you
So what do you need in order to like differentiate?
Okay, so what you need in order to differentiate is for each term to be written. Each term has to be written, sign, the coefficient, the variable written in the numerator, and then you've got to be able to see what the exponent is. You've got to have those 4 things in every single term before you can differentiate. Does that make sense? Because then otherwise you can't apply the power rule. The power rule is multiplying the exponent by the coefficient. So that's why you need to know what the exponent is, you need to know what the coefficient is, and then you've also got to know what the exponent is because you're going to be taking 1 away from it. Does that make sense?
Okay, yes. Does that need to, and it needs to be in every, like in every equation, if they give you solving for the derivative, this is the derivative.
Yes, that's correct. Yes.
Yeah, so then if they give you this, you have to have all 4 in like
every term. So in other words, between the pluses and minuses. So terms are separated by pluses and minuses. So each term. So if you look at this expression that we're looking at the moment, it's got 3 terms. Okay, so I'll just put some rings around it and then see if I can get rid of them. Okay, so Tioni, there is the first term. We write a term in math, sign, number, variable. Okay, and then there's the second term, minus t, whoopsie, my circles are so skewed, minus t squared over t. And then there is the third term. It's going to be positive 1 over t. So each one of those has to be written in the same way. Sign, the number, the coefficient, variable in the numerator with the appropriate exponent. So what we're doing here, as we go from line number 2 to line number 3, what we want to do is apply our exponent rules where it's applicable to do so. And in the last term, we can't apply an exponent law. What we're going to have to do is move the t from the denominator to the numerator. So keeping the dt, keeping the square bracket, t cubed divided by t would leave us with? Tioni, do you know?
Can you just repeat that again, please?
With pleasure. T cubed divided by t would leave us with what?
T squared.
Excellent. There you go. Perfect. All right. And now same question. Well, not same question, but almost exactly the same question. And now if you've got t squared divided by t.
Negative t.
Perfect. And then what would we do with the last term? Do you know?
Yeah, I'm confused. I'm not sure. No.
No, that's fine. Okay, so if I've got, I'm just going to write it here on the side. If I've got 1 over t, and this is a single factor on its own at the bottom, so a single term on its own at the bottom, I am allowed to take that into the numerator. So I'm allowed to take this from the denominator into the numerator, and I'm allowed to write it in the numerator if I change the sign of the exponent. So 1 over t can be written as invisible 1t to the power of -1. So that's our negative exponent rule. Does that sound familiar?
So sort of like additive, the inverse.
But the -1 means something different. For inverse functions, that -1 is a specific way of writing notation. Over here, what we're referring specifically to is our negative exponent law. So in other words, if you've got something like, let's say 2 over x, the rule is you are allowed to write that x in the numerator, provided you change the sign of the exponent. So you can write it like that. Or if you had a number like 3 over y to the power of -4, you were allowed to write it as 3y to the power of +4.
Oh, okay, I understand now.
Okay, all right, so that's the rule that we're applying in this case. So at the end here, we've got plus t to the power of -1. Okay, and now you are ready to differentiate. You're ready to take the first derivative. Each term is written number, so the numbers are invisible because they're ones. Okay, signs are there, so +1 in front of the t squared, t to the power of 2. So we've got our sign, our number, our variable, our exponent. Second term, our sign minus our number 1, our variable t, our exponent 1. And then again in the third term, we've got our sign plus our number 1, t in the numerator and our exponent. And now and only now are we allowed to apply the power rule. We're going to drop the dt, we're going to drop the square brackets, and we're going to multiply exponent with coefficient and then subtract 1 from exponent. So this will leave us with, let's ask somebody else. Shame, Tioni, you've been on the spot now for ages. Rekhomedetswe, do you know what the first term would be of the derivative?
The first term would be 2t.
Excellent, excellent. That's perfect. Well done. Nice job. Okay, and Lwazi, do you know what the second term is going to be? Lwazi? -1. Perfect, Lwazi. Well done. 100%. Okay. Perfect. Good job. Okay. Now let's call on somebody else. Luyanda, we haven't heard from you today. What's the third term going to be, Luyanda?
Isn't it going to be -t to the power of -2?
Fabulous. Well done. Well done, Matrix. That is brilliant work. Excellent, excellent, excellent. I'm really pleased. Give yourselves a round of applause. Definitely, definitely, definitely. Excellent work. Nice. Good job. Oh, lovely. Well done. That's lovely work. Okay, so I know that we've been talking a lot about question number 1, the green one. Is there anybody else that's managed to do either a purple or an orange question? Maybe you've got a question about something there. Anything you'd like to ask me at this point? I did orange. Well done, Neo. That was very brave of you. Are you ready to mark it? Live? Okay, same. So you also tried the beast question. Brilliant. Good job. So Virginia as well, thumbs up. Well done. So my suggestion to those of you that didn't manage to do the green question by yourselves, perhaps you want to copy the purple question down. And then you're also welcome to try it at a later stage. What I'd like to do now is just go and have a look at a couple of answers just for some of the other students, if that's all right. Those of you that are trying, maybe you're working on the purple question now, you can finish it off and then we can mark it as well. Okay, so let's go over here. Live and Neo, let's see what you did. So let's move that up. Hopefully everybody can still see that. Okay, so we don't want our purple answer. Oh, actually, I think the orange answer is all the way on the other side, which is not going to help us right now. Okay, never mind. We'll get around it like this. Let's just get rid of this block. Okay, the block's gone. And very quickly, just going to try and hide the purple one. There we go. Okay, so Neo and Live, have a look at that. Did you get the same answer as me? Hope I didn't make any mistakes. Oh, great. Osayo says yes, Live says yes, Neo says yes, a whole lot of thumbs ups. Oh, that's brilliant. Brilliant, brilliant. Well done, guys. Excellent. Oh, good. Well done. Well done. That's really great. That was a difficult question. So if you can do that one, you really are getting somewhere. Wonderful, wonderful, wonderful. Okay, let's carry on. If anybody wants to just quickly have a look at the purple question, if you tried that one as well, that's the answer that I got. Okay, so Live, you've given me a thumbs up. Well done. That's great. Okay, and then a whole bunch more. Okay, brilliant. Brilliant, brilliant, brilliant. Well done. I don't know if there's going to be time for us to do, I've written here do two. I'm not sure if there's going to be time for us to be able to do two. I think what we may need to do is come back to a little bit of this next week. Let's just have a quick look at a binomial denominator, and then perhaps what you could do is try and copy the first one down and see if you could do it as part of your homework. Oh, Acton Corsi, what are you saying? I'm actually proud of myself. I didn't know I could get the purple. Oh, that's brilliant. Well done. You see, you can do anything. Anything that you put your mind to, you can do it. I'm really happy for you. That's great. Well done. All right. Does anybody know what we would do if there was a binomial denominator? Have you encountered problems like this? Has anyone seen anything like this before?
Ma'am, can I try?
Please, go right ahead.
Would you factorize the numerator?
Perfect. Perfect. Tell me what to write.
Oh, no.
Oh, you've got it. I know you do.
So it would be the derivative of p, sorry.
Perfect.
Brackets. Then you'd open two brackets in the numerator.
100%.
And then the first bracket would have 2p.
Good.
The second bracket would have p.
Excellent.
And then I think the factors would be 2 and 1.
Careful, you're almost right. Just remember 2 times 1 is not 1. Remember
yes. So 1.
Perfect.
One.
So the first bracket is going to be 2p.
Plus 1.
Awesome. Second bracket?
2p, p plus 1.
Hey, you're a champ. Well done. Perfect.
P
And that's going to be over?
P plus 1.
Awesome. Well
And
done.
then the p plus 1, the two brackets cancel.
Oh, I love it. Brilliant. Okay, so the two brackets cancel. Fabulous. And now what do we do?
Now we differentiate.
Absolutely. So
So
now
answer
we
would be
differentiate.
2. The answer is just 2.
Quite right. The answer is just 2. Brilliant. Brilliant, brilliant, brilliant. Well done. That's really great work. I'm very, very happy. That's excellent. Very, very nice. In fact, it's funny how these binomial denominator ones seem to be a little bit easier than the monomial ones. Anyway, I've got to be careful. Last time we went over time. So I tell you what, let's just do 1. So instead of doing 2, let's do 1. If you are feeling particularly brave, then you can maybe try just 1. And I think maybe what we should do is treat this as our exit ticket rather than the questions that we've got there. Okay, so let's do it like that. Okay, so these are proper exam questions. As you can see, they've got mark allocations at the end. So these are the sorts of questions that you would encounter in your paper. So this would normally be the second question that you would get on applying the rules for the derivative. Let's see if you can go ahead and answer these questions. Well, just try 1. So there's either the purple one, which is quite straightforward, or you can try 7.22 or 8.22. So I'm going to give you for a couple of minutes to work on that, and then we'll discuss that and then we'll wrap it up. Okay. If you've got any questions, just shout, please. Sure, Nala. Let's just, might have to make it a little bit smaller. I hope everybody can see that. Okay, so Nala, what I'm going to do is just try and sort of move everything up a little bit. So that people can still see those questions over there. Okay, so there we go. We've managed to get everything on our screen. Nala, you said, I got everything, but I don't get how the answer was 2. Okay, so what we did between the second to last step and the last step, Nala, is we actually left out a step. But to be honest with you, it doesn't matter that we left that step out. But let me go and show you what should have happened here. Okay, rub out the 2. Are you happy with the factorizing and you're happy with how we got to the 2p plus 2? So what we would have done is, cool, so you're still happy with that. So in other words, we're going to take the derivative with respect to p, and the expression that we are differentiating is 2p plus 1. Okay, so that's what's left over after we cancel p plus 1 with p plus 1, right? Can you see that we're now ready to differentiate because each term inside the bracket is written sign, number, variable in the numerator with our exponent. Okay, so each of the 2 terms is written in that way. So now we're ready to differentiate. We're ready to take the first derivative. So we're going to drop the dp, we're going to drop the square brackets, and we're going to apply our power rule. So what we would have done here, just use a different color. All right, so remember we've got a 1 as the exponent on the p. So what we would have done is we would have said 1 times 2 is 2. Then we've got to take 1 away from the exponent. So that means you'd end up with p to the power of 0, and p to the power of 0 is 1. So 2 times 1 is 2. And then, Nala, as far as your second term is concerned, it's a constant. So the derivative of any constant is, you can put it in the chat. the derivative of any constant? There we go, 0. Perfect. Perfect, perfect. So can you see now why the answer would just be 2? Does it make sense? Does it make sense, Nala? That's fine, no worries. That's why we have to practice, okay? Because it is easy to forget. If we're not using it all the time and doing it all the time, we will forget, but no worries. Okay, so at least now it makes sense. Okay, so hopefully everybody is busy finishing off these questions over here. I know I said just do one, but if you do want to do more than one, that's not a problem. I think we might have like another minute or two to work, and then we're going to have to have a look at the answers. Is there anybody who's done one question and wants to move on? Well, you can send me a thumbs up if somebody's done a question. Okay, Tsepo, you got a thumbs up, lovely. Which one did you do, Tsepo? Did you do, okay, 2 thumbs ups, 3.
I did the orange one.
Oh, you did an orange one. Okay, very nice. The first orange one, Tsepo?
The second.
The second, oh, wow, I'm impressed, brilliant. Okay, so there are 10 thumbs ups at the moment. Okay, very nice, well done. Are we ready to have a look at some answers then? I just don't want to rush you, but we've got to finish in time. Are we ready to look at some answers? Thumbs up. Okay, 15 thumbs up. Wow, that's amazing. Okay, Neo, you say yes, you are ready to look at some answers. More thumbs ups again. Brilliant. 4, 5. Good. Okay, well, let's move over and go and have a look at these answers over here. All right, so I've drawn I've drawn little lines. That line actually belongs over there, and that one belongs over there, just because I moved everything. Okay, so let's follow the purple line. Anybody who did a purple question? This is what I got as my answer. So factorizing, crossing out x plus 1 with x plus 1. So we've got the derivative of x is, the expression is x minus 3, and the answer is 1. Anybody who tried the purple question, is that fine? Does that make sense to you? Perfect, and Tandukazi, well done, excellent, I'm so glad, that's great. Okay, thumbs ups are still going. Awesome, now let's have a look at the first orange one. Okay, there we go. And you can see this is an exam type question. You can see where the marks are allocated. So factorizing difference of squares is the first mark. Then taking 2 out as the highest common factor at the bottom. Cancelling 2x plus 3 at the top with 2x plus 3 at the bottom. That leaves us with 2x minus 3 over 2. And then what we would have to do is we would have to split it up. So in other words, we would write that as 2x over 2 minus 3 over 2. And then we would be ready to take the derivative. Okay, so who tried the second question and got it right? Maybe we're so happy. Maybe you can give yourself a that like little party symbol with a little hat, and or you can do a thumbs up. Okay, so 11 thumbs ups now. Zaya's got a thumbs up. Excellent. Well done. So another thumbs up. Zaya live. Atin Corsi, is that a, oh yay. High five. Luyanda's cool. Having a party. Nice. Are there any questions? Is there anybody who, yes, of course, Malu, ask a question.
Ma'am, why is the final answer 1?
Okay, no problem. Okay, the final answer is 1 because any constant term is going to become 0, right? So this minus 3 over 2 will become 0. So what we've got is the invisible 1 up here, the invisible 1 over there. So, okay. You got it now?
Yes.
Okay. All right. And then, I always finish late. I'm so sorry. Okay. So the last question, because I want you to see that before you go. Let's get that out the way. All righty. Okay, so there is the last question. I hope that's not blurry. Okay, so the last orange question. So we had to take y out as the highest common factor. That was 1 mark. Then writing it as 2 times x minus 1. So it's taking the 2x out as the highest common factor. Then we had to say x minus 1 divided by x minus 1. So that meant that we were left with y equals 2x. And then we were ready to take the derivative. Okay, so here, the derivative of y with respect to x, we got 2. Okay, so the people that tried that particular question, how did it go? Are you happy? Does it make sense? Tsepo's got a thumbs up. I'm so glad. 2 thumbs ups. Live says good. Oh, wow. That's great. Okay, so there are 7 thumbs ups. That's awesome. That's great, guys. Well done. So these are proper exam questions, straight out of past papers. So if you can do these, then you know that you're on the right track. Fantastic. You are amazing. Well done. That's really wonderful work. Is there anybody who wants to ask a question before we end off? We've got just like 1 or 2 minutes to go. And I think Michaela needs to talk to you. Any questions? Any last questions, anyone? Sure, no last questions? Neo, 8 out of 10. Okay, all right. So Michaela, do you want to address the learners again?
Yes. Okay. Yeah, well done, everyone. I think you guys did really, really well in this lesson, and you all deserve a thumbs up. So, yeah, I'm glad to see your understanding is getting a bit higher. Okay, I think also the participation helps. I think you guys are really, really following along with Lee, which is great.
Shame, Kanya for 5 out of 10. Sorry, Kanya.
Okay. Okay, so I'm just going to